Okay, so for our second review, we're going to be reviewing equations and inequalities. Let's go over some of our properties of equality. The first one is our addition property of equality. And that tells us that if we add the same number to each side of an equation, that's going to give us an equivalent equation. Equivalent, meaning an equal equation, the same equation, just looks a little bit different. So for example, if I have 10 minus 4 is equal to 6, what the addition property of equality tells me is that you can add 4 to both sides. Adding 4 is equal to adding 4. And if we do that, you'll get that 10 is equal to 10. You see how we got an equivalent equation? All right, our next property is the subtraction property of equality, and this tells us that if you subtract the same number from each side of an equation, you're going to get an equivalent equation, just like above. So for this example, let's use 10 plus 4. So 10 plus 4 gives us 14, and what the subtraction property tells me is that you can subtract 4 from both sides, and you'll still get an equation that makes sense. I get 10 is equal to 10. Next, we have the multiplication property of equality. This says that if you multiply each side of an equation by a non-zero number, you're going to get an equivalent equation. So just make sure that when you multiply, you cannot multiply both sides by 0. So the example we're going to use is, let's have 10 divided by 2 is equal to 5. What the rule tells me is that you can multiply both sides by 2 times 2 times 2. And you'll get that 10 is equal to 10. Okay, the division property of equality tells us that when you divide, so dividing each side of an equation by a non-zero number gives us an equivalent equation. So the example we'll use is, let's say 10 times 2 gives us 20. And what the division property tells me is that you can divide both sides by 2 and we'll get an equivalent equation. I get 10 is equal to 10. Okay, let's continue. So our next set of properties deals with several operations. I messed up. This one is called the associative, not associate. So associative property, it comes from the word associate, and it means you associate with different groups. So for example, let's have 10 plus 3 plus 5 is equal to 10 plus 3 plus 5. And what the associative property says is, let's pretend you're the number 3. Today you're hanging out with 3. Today you associate with 10, but tomorrow you're going to associate with 5. So it's just you're grouping them differently. The associative property uses parentheses. This can also be used with the multiplication. So 10 times 3 times 5 is the same as 10 times 3 times 5, depending on where I put my parentheses, depending on where the 3 associates with. Okay, the commutative property you can think about, you commute to and from a place. So 5 plus 4 is the same as saying 4 plus 5. I can reverse the order of these, okay? Again, this also works for multiplication. These two properties do not work for subtraction and division. And the last one, your distributive property. You can think about you're distributing something to your friends. We use this with multiplication over addition or subtraction. So when I have this, you take your 5 and let's distribute it. 5 times 3 gives you 15. And then 5 times 10 gives you 50. This is the distributive property. Okay, let's continue with the next page. First question says, when solving the equation 4 times 3x squared plus 2 minus 9 equals to 8x squared plus 7, Emily wrote 4 times 3x squared plus 2 equals 8x squared plus 16 as her first step. Which property justifies Emily's first step? So it's really difficult for me when I'm reading it like this because it's not written in a way I usually see. So I'm going to rewrite it. So I guess the problem was 4 times 3x squared plus 2 minus 9 equals to 8x squared plus 7. And Emily's first step, this is what she did. 4 times 3x squared plus 2 is equal to 8x squared plus 16. Okay, so we're trying to figure out what she did to go from that red step to this blue step. See if you can figure it out before we go over it. So what I noticed is different about these two steps is that her 9 is no longer there. She must have moved the 9 to the other side by doing plus 9 is equal to plus 9, which makes sense because that's how she gets the plus 16. This property is called the addition property of equality. Okay, so these next set of problems, which we want to do is solve the equation while justifying our steps. So let's work on this first problem together. The first thing I notice, it says 2x minus 9 equals to negative 10, and that changes to 2x minus 18. This must have occurred through the distributive property. So to go to this step must have been distributive property. All right, let's take a look. How do we get to our next step? After, what I notice is different is that there's no longer the minus 18, so I must have done plus 18 on both sides. Since this is adding, this is the addition property of equality. And then step 3, I have 2x equals to 8, but in step 4, I only have x equals to 4. So I must have divided both sides by 2. And since I am dividing, this is the division property. So go ahead and pause the video here and see if you can do the next problem by yourself before we go over it. All right, the next question says 5y minus 1 divided by 2 equals to 7. The first thing you're going to want to do to solve this problem is to get rid of the divide by 2 by multiplying both sides by 2. Then you'll get that the divide by 2 and the multiply by 2 cancels each other out. And now you have 5y minus 1 equals to 7 times 2, which is 14. This was the multiplication property. Okay. Next, to get y by itself, we're going to want to add 1 to both sides so that your minus 1 and your positive 1 will cancel out. I get 5y is equal to 15. Adding 1 means this is the addition property. Okay, these properties are essential to algebra. Okay, and last but not least, I have 5y equals to 15. To solve for y, let's divide by 5 on both sides. I get y is equal to 3. This is the division property. So if you feel like you're ready to do the next one, again, pause the video here and try question 6 on your own. All right, welcome back. If you're ready, let's go over question 6. If not, again, pause the video so you can finish it before we go over it. The first thing you should try to do is get rid of those parentheses by distributing. So, negative 8 times w, I get negative 8w. Negative 8 times positive 1, I get negative 8 equals 2. And let's distribute on the other side as well. Negative 5 times w, I get negative 5w. And negative 5 times 10, I get negative 50. This was distributive property. So the next thing you want to try to do is to move your variables to one side. I notice there's a 5w, negative 5w on my right side. I want to move that over to my left side. So I'm going to add 5w to both sides. I get negative 3w minus 8 equals to negative 50. Now, why am I able to add 5w to both sides? That's thanks to the addition property. Okay, let's keep going. Let's move the negative 8 to the other side by adding 8 to both sides. I get negative 3w is going to be equal to negative 42. And since I added, again, this is still going to be the addition property. last but not least, let's get w by itself by dividing by -3 on both sides. Divide by -3 on both sides, you get w is equal to 14. And what allows me to do that is the division property of equality. Okay, nice work. Okay, let's turn to the next page. Now that we have the properties down, let's just work on solving some algebraic equations. If you would like to try to do these problems on your own, please pause the video. Otherwise, we're going to go through it. So for this first problem, the first thing we want to do is get rid of the divide by 3, and we're going to do that by multiplying by 3 on both sides. You'll get that multiply by 3 and divide by 3 cancels out. So I get x plus 7. And on your right side, you get 2 times 3, which is 6. The next thing you want to do is get x by itself by subtracting 7 from both sides. This is the subtraction property of equality. Subtract 7 from both sides, the 7's cancel out, I get x equals to -1. Okay, again, to get x by itself, the first thing we want to do is move the positive 6 over to the other side by subtracting 6 from both sides. So that will cancel out. I'm left with -5 over 2x is equal to -5. And here's where it's a little tricky. Anytime you want to get rid of a fraction, what you want to do is multiply by its reciprocal. Reciprocal means to flip it. So I'm still keeping the negative. All I did was flip the numbers. I'm going to multiply by -2 over 5 on both sides. That'll help you cancel out the -5 over 2. You're left with x. If we plug this into our calculator, we'll get that x is equal to 2. Okay, problem below, again, we have parentheses, so the first thing you want to do is distribute. 7 times 8n, I get 56n plus 56. And now I have a -7, so make sure you're distributing the -7. It becomes -56 plus 56n equals to the rest of this problem. So n plus 3 minus 7 minus 5n. What I want to do next is combine like terms. So on my left side, 56n combines with, oh, I must have messed up. This is a -56. Okay, because that was -7 times +8. So that gives you -56. So positive 56n and -56n, they actually cancel each other out and we get 0. And then positive 56 and -56 also cancel each other out, so we're left with 0 on the left side. It doesn't mean your answer is wrong. 0 is a real number. So on my right side, let's combine like terms. I got n and -5n. That gives you -4n. I got a positive 3 and a -7. That gives you -4. So to solve for n, let's get n by itself by adding 4n to both sides. I want to move all my variables to the left side. I'm left with 4n is equal to 4. And last step, to get n by itself, we're going to divide by 4 on both sides, and we get n is equal to 1. Okay, so I made a mistake, and it just goes to show that everyone can make mistakes. Over here, and if you caught it, awesome. If not, maybe try to figure out where the mistake is. But when I crossed out this and I brought down my 4, and this happens to you guys all the time, and it happened to me, I forgot my negative. So this should have been -4 divided by 4 gives you a -1. All right, let's recover from that and move forward. So we go from multi-step equations to figure out how to do literal equations. Let's solve this first equation very quickly. The first thing you want to do is subtract 3 from both sides. I get 5x is equal to 30. And then divide by 5 to get x is equal to 6. So using this example, let's figure out how to do the right side. Well, on the left side, the first thing I did was subtract 3. So it makes sense that the first thing I do over here is subtract b from both sides. And I get ax equals to c minus b. And now if I want to solve for x, you want to divide both sides by a. So x is equal to c minus b divided by a. So go ahead and see if you can do the 2 problems in the back before we go over it. You can pause the video here. Okay, so let's continue where we left off, and we're going to try to do these 2 problems together. I'll refer to them as the yellow problem and the green problem, or the regular equation and the literal equation. Okay, so let's first look at our regular equation. It's highlighted in yellow. I have x plus 5 divided by 2 minus 7 equals to 3. And the first thing you want to do is move that 7 over to the other side by adding 7 to both sides. Okay, that's really big. So that. Okay, after you add 7 to both sides, you'll get, well, this is now x plus 5 divided by 2 is equal to 10. This is not the pencil tool. There you go. Okay, so on the right side and highlighted in green, what you want to do is the same thing you did here. What is equivalent to minus 7 in our green equation? And that's going to be the minus c. So what you want to do is bring that over to the other side by adding c to both sides. Okay, so you want to add c to both sides of your equation, and you're going to get x plus a divided by b on one side is equal to, since I cannot combine b plus c because I don't know what they are, you're just going to rewrite it. Okay, so now let's take a look. The next thing you want to do on the left side is multiply both sides by 2 so I can get rid of the divide by 2. Alright, that's going to cancel out. I'm going to have x plus 5 is equal to 20. Okay. Same thing, I want to multiply by b since that's what I'm dividing by. And now take a look. I have to multiply the entire sum, right? I multiply 10 by 2, not just d, not just c, not just 3, not just 7. You need to multiply the entire thing by 2. So, sorry, by b's. The b's are going to cancel out there. I have x plus a is equal to b times d plus c. Okay, the last thing we want to do is subtract 5 from both sides. I get x is equal to 15. And over here, I'm going to subtract a from both sides. And I'm going to get x is equal to b times d plus c minus a. Okay, let's take a look at this next problem. This next problem, I have variables on both sides. So what you're going to want to do first is, let's bring our variable over to one side. I'm going to minus 5x from both sides. Okay, and I get 3x plus 1 is equal to 22. All right, so let's finish this. I'm going to take away 1 from both sides. I get, listen, I should have caught this out too. 3x is equal to 21. And last but not least, let's divide by 3 on both sides. You get x is equal to 7. All right, same thing. The first thing I did was move the x over. So minus cx from both sides. This canceled out. I get ax minus cx plus b is equal to d. Okay, and then I move the 1 over, which is the same as moving my b over here. And I get ax minus cx equals to d minus b. And this is here where it might get a little confusing because I have 2 x's. Okay, where did this 3 come from? Well, the 3 came from combining 8 and 5. So what you want to do is combine the a and the c. Or we can see it as factoring out an x. If you factor out an x, you're left with a minus c inside is equal to d minus b. And then all you have to do is divide by a minus c, since that's one entire factor. Okay, if you divide by that, a minus c's cancel out. You get x is equal to d minus b over a minus c. Okay, so let's continue. We're going to talk about inequalities now, and I need you guys to write this nice and big. I'm going to be making sure that it's written in like capital and big, and it's very noticeable. So when you multiply or divide by a negative number, you must flip the inequality symbol. Well, symbol. Okay, so anytime you multiply or divide by a negative number, you have to flip the inequality symbol. And then down here, let's just fill it in. Closed circles are for less than or equal to or greater than or equal to. So it has the or equal to sign. Open circles are for less than or greater than. So these don't have the or equal to. So if it has the or equal to, it gets a closed circle. Okay, so this is the only new rule we talk about when we talk about inequalities and then how to shade them. So let's do the first problem together. Let's solve for x. The first thing you want to do is add 6 to both sides. And I get 5x is less than or equal to 30, because 24 plus 6 is 30. Let me erase that. Okay, so 24 plus 6 is 30. And now what you want to do is divide by 5 on both sides. And I get x is less than or equal to 6. So, first things first, let's put an open circle at 6. And now let's think about our numbers. 6 is here, and on either side is 5 and 7. I want numbers that are less than 6. And I just want to test these two numbers, and I want to ask myself, is 5 less than 6 or is 7 less than 6? 5 is less than 6, so we're going to shade towards 5. Okay, see if you can complete this next problem by yourself before we go over it. You can pause the video if you're ready to go. Let's get to it. So, first things first, let's move the 6 over by subtracting 6 from both sides. I get negative 4x is greater than 12. And now to get x by itself, we're going to divide by negative 4. And here is our new rule. Since I am dividing by a negative, my inequality symbol must flip and now becomes less than. So x is less than negative 3. Let's locate negative 3 on our number line. And we're going to put an open circle because there is no or equal to. So negative 3 is here. And let's think about the numbers on either side. I have negative 4 and negative 2. I want the numbers that are less than negative 3. Less than negative 3, well, negative 4 is less than negative 3, so I'm going to be shading towards negative 4. Okay, again, if you want to try this problem on your own, pause the video, otherwise we're going to get right to it. So, first I have parentheses, so the first thing you want to do is make sure you distribute, and make sure you distribute a negative 6. So let's bring down everything else. I have 8x. Negative 6 times x gives you negative 6x. Negative 6 times negative 2 gives you a positive 12. And I'm going to rewrite the rest of the problem. 20 minus 2x. Okay, let's combine like terms. 8x and 2x gives me 8x and 6x gives me 2x. Nothing to combine the 12 with, so let's just bring that down. It's greater than 20 minus 2x. Okay, move all your variables over to the left side by adding 2x to both sides. I get 4x plus 12 is greater than 20. And let's move all our constants over to the right side. I'm going to subtract 12 from both sides. I get 4x is greater than 8. And last but not least, we're going to divide by 4. And we get x is greater than 2. So notice we don't have to flip our inequality symbol because we divided by a positive number. Let's locate 2 on our number line. We get an open circle because we don't have the or equal to. So an open circle at 2. And now think about the numbers on either side. I have 1 and 3. And if I go back to my solution, I want the numbers that are greater than 2. So greater than 2, that means, well, 3 is greater than 2. So I'm going to be shading this way towards 3. Okay, we're almost there. Last page. So this is an inequality involving variables, and let's see if we can solve it. Okay, so right here is a very important part. The problem says ax plus b is greater than d, and a is less than 0. That tells you that a is negative. If it's less than 0, it must be a negative number. Okay, so let's see what we can do with that information. I have ax plus b is greater than d. To solve, the first thing I'm going to do is subtract b from both sides. And I get ax is greater than d minus b. And then divide by a. So everything is pretty straightforward right now. I get x and then d minus b over a. And so here's the one thing that we have to remember. A is a negative number. So when I divide it by a, I need to make sure that I flip my inequality symbol because from the problem A is negative. Okay, so x is less than b minus b over a. That's answer choice 2. Okay, 2 more problems. We got this. So which value of x is in the solution set of? I always like to rewrite my problem where there's space for me to do it. So 4 divided by 3x plus 5 is less than 17. First, let's subtract 5 from both sides. And I get 4/3 x is less than 12. And if you remember, the way we get rid of a fraction is by multiplying by its reciprocal. Okay, so multiply by its reciprocal just basically means flip the fraction. So I'm going to multiply by 3 over 4. And I'm going to multiply by 3 over 4. So this will cancel out, and I get, well, I didn't divide or multiply by a negative number. I did by a fraction. That's okay. 12 times 3/4. If you go ahead and plug that into your calculator, I get x is less than 9. Now, a lot of you are going to be tempted to circle answer choice 2 because we got 9. But keep in mind that if I were to graph this on a number line, this is 9, this is 8, this is 10. I have an open circle at 9, and I want all the numbers less than 9, so I'm shading towards the 8. Open circle always means that it is not part of the solution, so it cannot possibly be 9. You notice that 8 is shaded though, so 8 is going to be part of my solution. 12 and 16 are on the other side of 9, which is not shaded, so they are not part of the solution. Okay, last problem. Given 2x plus ax minus 7 is greater than negative 12. Determine the largest integer value of a when x is equal to negative 1. So again, let's just copy over the problem. So 2x plus ax minus 7 is greater than negative 12. Okay, well, they tell you x is equal to negative 1, so why don't I just, try to plug that in? So instead of writing x, I'm going to replace that with negative 1, but everything else will stay the same. Minus 7 is greater than negative 12. And let's do some simplifying. So 2 times negative 1, that's negative 2. 8 times negative 1, that's negative 8. Minus 7 is greater than negative 12. I can now combine like terms. I have negative 2 and negative 7 gives you negative 9. Minus a is greater than negative 12. And we're trying to solve for a, right? That's our only variable left. So let's add 9 to both sides. Gonna need more room. Okay, so I have negative a is greater than, this is going to give you a negative 3. And we're almost there. There's still a negative in front of the a, so what you want to do is divide by negative 1. And what's that new rule again? I divided by a negative, which means that your inequality symbol must flip. It is now a is less than 3. Where can I do this? Okay. I'm going to move everything down. Up. Okay, it's fine. Whoa, okay. So let's just try to visualize this. I'm going to do it in green since I haven't written in green for a while. It'll be easy to see. So I have 3, I have 2, and I have 4 on either side, right? So a is less than 3, which means we get an open circle at 3, and I want all the numbers less than it. So again, remember that an open circle means that it's not included in the set. So I want the largest number that works. Well, let's take a look. 4 doesn't work. It's not part of the solution set. 3 doesn't work because there's an open circle here. So the largest integer value that works is going to be 2. A is equal to 2. Okay, so you guys will see that there are, I think, 5 practice problems for you to complete. Please complete these on your own to the best of your ability and bring them back to class. If you have any questions, let us know.